coming to the limitations of Bohr's atomic model. In the introduction, we have seen that Bohr's model was the first atomic model to introduce the quantum concept, and though it had successfully contributed to many things, but there were some limitations and there were some discrepancies, or there was some kind of limitation which it had, so that we had to move for a further and better atomic models, and what are the different other atomic models that we have discussed already in our introductory class. But now let us look what are the various limitations that Bohr's atomic model have, which had to be, so that it had to be left out, and we had to move on to the next problem, to solve next problem using various other atomic models. So what happened as Bohr's atomic model successfully explained the spectrum and the spectral line of hydrogen atom. But what happened that during the complex atomic spectrum, complex in the sense when the electron numbers got increased, in the sense if you go higher to the elementary in the periodic table, the higher atomic number of complex elements, then whatever spectrum that we were getting for those elements could not be explained by the Bohr's atomic model. Bohr's were showing just a particular jumping of electron from one particular orbit to another orbit. But as we rose into the complex higher level elements, it was not possible to explain why things are happening. There were certain spectral lines, and there was certain spectrum that we are seeing, which cannot be explained just by Bohr's three postulates. Therefore, we had to look for different atomic models. The second thing, the intensity of the spectral line. In the spectrum, few lines were very bright, few lines were very faint and almost invisible, but they could be seen only in a very, very dark room, and not be very easily visible if there is a bright light. But certain lines were very bright, certain lines were very dimmer. So why such intensity variation in the same transition of the electrons, where Bohr said that similar amount of energy would release? So there has to be some explanation as to why this intensity were varying, which was not being able to explain by Bohr's atomic model. Third one is a fine structure. Sometimes what happened in the spectral lines, some lines, if we have a very, very proper resolution or high resolution instruments, we could see what was actually looking like one single line was not a single line, but they are actually made up of many small lines, one or more small lines. Means there are in one band or in one small line, it is made up of much finer lines or much finer structure that was found, or that was seen in a high resolution spectroscopes. And Bohr's simple atomic model with three postulates could not explain as to why such kind of small fine structures are that we are able to see. The third thing is it was seen that suppose the same hydrogen spectrum, whatever lines that we see, or any spectrum, the lines that we see were kind of explainable and or not, and these lines in the presence of electric field or magnetic field, it would just split into many lines perhaps. So in the presence of electric field or the magnetic field, miraculously or very interestingly, the lines got split up into many lines. So why such things are happening, how electric field and magnetic field is interacting here for the atomic spectrum, and how the splitting is happening, this whole thing was not being explained. by Bohr's atomic model. This effects or this phenomena, they are called Stark effect and Zeeman effect. If the lines got splitted in the presence of magnetic field, we call it as Zeeman effect. If the line got splitted in the presence of electric field, we call it Stark effect. So Stark effect or Zeeman effect, or the splitting of lines in the presence of electric field and magnetic field, were not been able to explain by Bohr's three postulates that we know. So this is one more discrepancy that we see. And finally, it has been seen that the electrons were not only were there in proper discrete orbits. So there were some shells of this orbit, and there were pretty subshells of this orbit. So these orbits are not only enough to explain the electron's position or to define electron's position. There were shells and subshells of these orbits, and electrons were filling up into various kind of proportion and various measurement to these shells and subshells in the same orbit itself. So which was not been explained by the Bohr's atomic model. So these are the various discrepancies, these are the various limitations that we found that Bohr's atomic model has to be rejected, and it cannot it pretty much explains to a certain level like hydrogen atom, but when it comes to various other things like splitting of spectral lines, intensities of spectral lines, the Stark effect, Zeeman effect, filling of subshells and shells, or why such complex atom has such kind of spectrum, this were not been able to explain by just three postulates that Bohr has given. So therefore these are the limitations of Bohr atomic model, which had kind of pushed for the looking or the discovery of the next available atomic models.
If you like the video, then press the like button, subscribe to the channel and press the bell icon.